So you folks seem to have enjoyed some of the how-to videos I've done. So let me show you how I took a $70 bead roller and turned it into what is kind of almost a professional grade bead roller that's been working really good for me. Oh, hey folks, welcome back to KEI Fabrication. Alright folks, it's been a long time since I've worked on this piece of equipment here. I bought that when they went on sale at Harbor Freight. It's a bead roller. Most of you are probably familiar with what it is. I'll put a bunch of links in the description below that explains the changes that make these a much better machine. And you'll watch me build those. The reason why I haven't released this video yet, and it's taken me a while, is I've been saving my nickels and dimes for what I consider one of the most important things you can do to make a bead roller functional, especially single-handed. Now I've seen a bunch of, I'll explain what that is in a minute. I've seen a bunch of people make modifications to these bead rollers in the form of putting a power tool where the handle is, putting an offset wheel so they can push the wheel with one hand. The shop that I was trained in many years ago bought a real one of these, and it had a power drive roller with a speed regulator and a foot pedal control, and that is absolutely the best scenario for one of these. But that drive, if you do it with a power tool, sometimes it ends up being too fast and you got to have bicycle chains or go-kart chains and sprockets and everything. It just really becomes cumbersome and the speed is too fast still, or sometimes it's underpowered, and when you get into thicker material it ends up stalling out. So I hope what I've done here is I've purchased a good quality drive system. Now there are a couple of drive systems on the market. This one probably isn't the best one. However, I went to buy even a more expensive one and it was out of stock. This one was in stock. There are some characteristics of this that I liked that I'll show you in just a minute why I decided to give this one a try. Alright, this is take 2 of this. I didn't realize that you folks couldn't see a darn thing that I did, so here we go again. So the reason why I chose this is it has a real high torque DC motor. It has a controller with pulse width modulation. What that means is you can vary the speed of the motor and maintain the amount of torque throughout the entire RPM range. It has a forward, neutral, and reverse switch and a foot pedal. So to do a good job with a bead roller, you really need to be able to put both hands on the material to steer it, and then the speed control will allow you to slow down when you get to a turn and then speed back up as you get to a straight. And another problem with some of the techniques using a power tool is when you let go of the power or turn the power off, the motor coasts. And when it coasts, it could overrun or overshoot your sketch on your workpiece, and you're not getting what you expected. So again, I could never afford this, a really good bead roller. I had to start out with, you know, the $99 thing and then spend the money on the drive system. When I'm all said and done, hopefully it'll work almost as good, and maybe I saved $800 or $900 bucks. So one of the things that I was explaining when the camera wasn't focused on anything is the mounting bracket is supposed to accommodate the stock location of the drive system for a China brand bead roller, and the coupling is supposed to fit on a 25 millimeter shaft. So I'm hoping that that's a 25 millimeter shaft. This particular one does come with a Lovejoy coupling, or a reasonable facsimile of a Lovejoy coupling. So it's got the 25 millimeter on this side, and then it has the smaller shaft diameter for the drive motor system. So let me see what I need to do to get this thing mocked up and maybe get it plugged in and see if it works, and we'll go from there. So I just want to state for the record that I did purchase this outright from Eastwood. Again, I was really looking at a Mittler Brothers version, or Power Master, I think is the other one that Summit sells. They were out of stock. I wanted to get this in as soon as possible because that thing in the background over there is waiting patiently for me. I've got the sheets of brand new sheet metal to start making the firewall and those things. So I wanted this up and running, and they said it was going to be like a late April delivery, and it's the end of March now, so you were at least talking 30 days before I'd ever see it. So that's why I chose this. So if nothing else, this will become a test of the Eastwood version of this. Again, not sponsored, paid full price, and I bought it basically because the specs on the system seemed good and the design of the system seemed good. Now the only real question mark is the fitment and the adaptation and the performance. So step one of the test is the 25 millimeter shaft, and the silver coupling slips perfectly onto the shaft, and the set screw will go on the flat spot on the factory shaft. So there's one check mark in the win column in terms of not having to machine out a coupling or purchase one. The one that was supplied with the Eastwood kit so far fits perfectly on this unit. Alright, so step two is just to kind of see if this thing is going to be user-friendly in terms of mounting, and the coupling fits on the drive motor well, like it should, and it seems as though it's going to fit on the other one as well, and it does look like it's quite possible that the mounting holes here are going to be acceptable. Just removing these bolts, putting this plate on, putting the bolts back in. The only thing I'm seeing right now is that the distance from the Lovejoy coupling to the drive shaft of the thing, I may have to trim this back slightly, and I'm going to have to use spacers and longer bolts to make it work. So I don't have enough engagement on either one of the couplers right now because this bumps into the mount. That's not the fault of Eastwood. That's how I chose to mount this to the stock or as supplied bead roller frame. These improvements you'll see in the previous portion of this video. You'll see that these improvements stop the deflection and the bending when you're trying to do some aggressive bead rolls. So this is my fault, not theirs, and I've just got to do a simple trim here and make some spacers from the C-frame of the bead roller to the mounting bracket of the drive system. So in reality, it's not a big deal. So alignment of this thing is going to be critical, so you don't bind up the motor and create any wear problems or just rob a whole bunch of power from the drive system when you're trying to do the bead roll. So I'm going to get some measurements of these spacers, and I'll trim this back, and then we'll start bolting it up, see how it goes. So with the drive motor system mocked up in place where the bolts go, and I have the coupling on, I have almost a comfortable amount of coupling engagement. I don't know if you can see it, but there's a Sharpie marker line there that's, I'd say it's about 5/8 inch from the edge. So to get what I would consider a safe amount is I've only got to take about 1/4 inch off of this, and that'll still leave this hoop connected with another 1/4 inch of material. So I'm okay with modifying that. That to me is a good solution. However, the second I take an axe to this thing, warranty's off, right? So that's the only downfall. The other kind of shout out I want to give, it's an attaboy, and then, you know, I got to take it back, but when you line this up, there's a space here, and I have to give credit in one direction to Eastwood, because when I opened up the hardware package, they actually have spacers that'll go here, and some washers to help the spacer reach over the some spacers to reach over this slot. They're just barely big enough to go over, and then the spacers. So they provided spacers. However, the metric bolts that hold the bearing blocks on, that go here, are of a different size. So the bolts that Eastwood supplied in their hardware kit, I think these are probably 12 millimeter, and these are probably 14. So nothing a trip to the hardware won't fix. So before I go and hack that piece off, I still have plenty of engagement here on my shaft for the coupling to run a test. So once I get the long bolts of the correct thread, I should be able to get this thing mocked up and actually do a quick test on it before I modify it to make that little coupler fully engage. So let me go to the parts store and we'll see if we can figure this thing out. Alright, so I had to run to the hardware store and pick up a new bolt. Now the bolts that were supplied in the Eastwood kit were 12 millimeter by 175 pitch by 60 millimeters long, and they came with the spacers to fit those bolts. However, the correct bolt that was going into these bearing blocks is a M14 by 2 inch pitch by 60 millimeter, and the hardware store only had one, and the one that I purchased had the shouldered or washer head bolt, so that works nice on this slotted assembly. The spacers that they sell or come with the Eastwood kit only fit over the 12 millimeter bolt. They don't fit over the 14 millimeter bolt, so I had some aluminum stock that I turned down and faced off so they're perfectly parallel, and bored the hole on the inside to fit the 14 millimeter bolt. The measurement that this bushing is made at is like 1 inch 0.00, so it seems as though it's aligned well, the coupling's aligned well, and just the very first try of plugging the motor in and turning it, if there was an issue with alignment, the motor would be traveling up and down and flexing for two reasons. First of all, it's only held in by one bolt right now. So this is wide open with the foot pedal down, and it may not look like it's going very fast, but if you were trying to chase a line on a piece of sheet metal and going that fast, you would realize that it's way too fast. So again, the reason why I chose this system is it had a gear motor in it to drop this ratio down to 75 to 1, and then you get a RPM control where you can really fine-tune your speed and maintain the full output torque of the motor. So I haven't put a piece of metal through it yet. This is the first time this thing's been turning, and again, I'm just testing it because I've just barely got this set screw on the shaft, and this one is kind of spaced like a 1/16 further this way than the end of the shaft being flush with the end of the coupler. But it should be plenty to do what I'm doing, and it's a test to see how this thing performs before I go ahead and modify this right here. So I have two options here. I can take a slice out of my reinforcing tube and cap it off, and that would allow this to move ahead. So that's one option. I may do that just in case something goes wrong with this. If I remember correctly, this has a 1-year warranty. The spacer that I made is 1 inch in diameter, so it has pretty good wheelbase, if you will, to get around these slots. And again, the metric bolt with the washer head on it acts as a great flange to capture this thing. So I've got to go to another hardware store because, again, this particular hardware store only had one of these. So next time I'm out and about, I go to a different one, I know exactly what to get. So let's get a piece of test material and see how my step flange tool works. Again, I haven't used one of these motorized version. I've done some basic stuff for making patch panels in the last 6 months or so, and my son has used it quite extensively to make some patch panels for his '67 Chrysler New Yorker. But as far as making some very precise and accurate panels that are going to be visually seen with bead rolls and things, I have never used this machine to do that. So I'm hoping that this capacity and capability of this machine will get us to the point where this works almost as good as one that costs 4 times the money. So all of these improvements with the spring to pull up on the blocks automatically when you're releasing the tension, these are all suggestions that were made by other fabricators that modified their units. I put the grease fittings in, I did the reinforcing on the back side, I built the cart on wheels, the holders for the dies, and now I've added the drive system, which I really think is, out of all the modifications you could do, this is going to provide you with the most versatile use and accuracy, and really be happy with what your results are. So far I really like the drive system. Obviously I haven't run a piece of material through it at all, so we'll update you on the performance in terms of the speed should be nice and steady as you're running the bead roll. It shouldn't, if the motor was too weak or didn't have enough torque, the speed would increase and then decrease, increase and then decrease, and it really makes it difficult to follow a nice straight line. The foot pedal that comes with it is actually very nice. It's all metal. It has the little foot stop, and my intention is to make a little box tube holder for it so it's not dragging around on the ground when I park this thing. And now that I have power cords, I'll have a bracket on here to wrap the power cords around. Again, this is now a fairly big investment, but it's a tool and I want to take care of it, and I want to make sure that I'm not stepping on the cords or I'm running them over with the wheels when I'm putting it away. So let me get together a couple of test pieces and we'll see how the drive system works. So all as I'm doing here is putting an offset flange all the way around this, and I've got the motor setting at a very slow speed because I'm new at this and I'm relatively uncertain of my skill to follow the line here, and it has really given me the ability to control this thing. I don't have brakes on my stand to hold this in position, so if I was trying to do this basically solo and turning the hand crank, I'd be chasing this around, and if I had put a hand wheel on like some people do without a braking system, I'd be chasing it around, and I would have to have a fence on this thing to stop my material from moving. So far I am extremely happy with this system. I'm still under just the test mode. It's really just kind of mocked up. There's only one bolt holding this thing in, and it's working fantastic. And I've really got the speed setting turned way down. I'm only about a quarter of the way up, and I kind of like the speed where I'm at right now, again because I'm uncertain of my ability, and it really is giving me the opportunity to control this. Very nice straight edge. I've only put one turn down on the offset die. If you put too much pressure on it, and it really does a number on the material, you can see that it's not changing the shape of the thing at all. So what I'm going to do now is I'm going to change the dies over to basically a medium-sized bead, and I'm going to try and follow my traced out test sample here, and I'm going to make the bead come out towards me. And like so many other people do for their tracing out their radiuses on their pattern, the 4.5 inch cutting wheel, the real thin one, works out so nice. I've seen people use, a roll of tape, but cutting wheels or grinding wheels make a great radius, and that radius is forgiving. It's not so sharp that you can't turn the material. Again, I'm only using 30 thousandths aluminum, but even with just the flange all the way around, it's really nice. It's firmed this thing up already, and more importantly, I think the money I spent on this drive system, as long as it operates well for a long period of time, so far I'm very impressed with the Eastwood bead roller drive system. Alright folks, here goes nothing. I've swapped the dies out. I'm starting in the middle of my run here, the straightest, longest edge. I've just barely made contact with the work. I've centered my sketch in the middle of the bead, and I just realized I put the dies in backwards. Hold on. Alright, so I swapped the dies over. I did my trace, and I want the bead to come up towards me. So I've got the female part of the die on the upper roller and the male part of the die on the bottom roller. So I'm going to try one turn of my device that provides the pressure, and I'm going to try and run this. If I was to do this again, I probably would have traced it in a different location. This speed seems to be really good for turning this corner. It's a little difficult to line up because I've got to eyeball the center of the female portion of the die, and that's a little more difficult than if the male portion of the die was facing up. So again, I like the speed. I'm not rushed. I'm not chasing my machine around the floor. And with a little practice, I think this will be a nice machine to make some cool designs with. So let's see how I did. So I even was able to match up this pretty well. I might have had too much down pressure. I do have a little bit of distortion in the piece, but if I was putting this panel into something, I could probably just tweak it into position. So I mean, that's my first try ever using this machine with a powered bead roller, and I made the transition from the start to finish. I was able to line it up good. The bead is kind of good looking from either direction, and the speed control and maintaining the torque is absolutely critical in doing good stuff with this. So this is a keeper. This is a win-win for me. I'm going to mess around and practice some more, just to try and understand what the best way to do this is, and just kind of work on my skill. I'm a little wobbly on some of my corners here, so I just have to get better at thinking far enough ahead to get my patterns traced out on the correct size of my work, correct side of my work, so it would have been a lot easier to target my sketch line around. And also, if my sketch line was narrower and I had a thin Sharpie instead of a worn out thick one, and had the male die up top, it would have been a lot easier if I had done the approach from the other direction. So anyway, if you are looking for a drive system for your China bead roller, I actually, so far, I would not hesitate to purchase the Eastwood version. I believe it's the least expensive version out there. I think the next one, the Mittler Brothers, is like $380 something, and then I think the Power Master one, or whatever that manufacturer is from Summit, is like $480. I didn't buy this because it was the least expensive. As I said in the beginning, I bought it because it was available and it was shipped here within 3 days. So, and here I am in the matter of an hour. I've got it hooked up to my machine and it's working. So to me, that's a win-win. Whenever you buy something and adapt it to your machine and it's working for you, I think that's always a plus. The next test will be on some sheet metal. I don't have any good clean steel sheet metal. My sheets right now are in full 4x8 sheets of 20 gauge that I'm going to be making the firewalls for the old modified, and I'm going to make the door skin. One of the ambitious things that I want to try and do with this bead roller is I want to try and make a die that'll come close to replicating this beaded edge on this Chevy. I'm going to replace the quarter panel from here down and the door, and the bead on the door is absolutely destroyed. So if I could put something that was close to resembling that bead in my door skin that I'm going to fabricate out of new sheet metal, it would save a lot of work, and it would make it look closer to what a 39 Chevy body is supposed to look like. So I'm going to spend some time on my lathe and making up a set of dies, and see what I can come up with. It's an experiment. It's something that I enjoy doing, trying to figure this stuff out, and I'll run some test sample pieces and tweak the die as necessary. And I gotta like grind my own cutting tools to make the cut in both the male and female dies, and I just gotta practice with it and see if I can make it happen. I'll let you know how that makes out. I could be fooling myself, but it's stuff I like to do, and I have the equipment to mess around with it. And maybe I can build a prototype and have a machine shop actually make a production version of it. So anyway, that's my plan. That's about the extent of my messing around with this today. Like anything, when you get a new toy, you really want to see what it's all about. A couple of things I got to do. I got to make the holder for the foot pedal, like I said. I got to make the little wrap on the post for the power cords, and I am going to, there's a 9/16 wrench that's required for these and a 3/4 wrench if I need to adjust the bearing blocks. So I'm going to make little hooks on the tower here, and I've got some of my triplicate wrenches that I'm just going to dedicate to this machine, and they'll be hooked to it. And I've got one die that keeps falling off. I made my little stanchions for the dies too short. One of them is too short, so when I move the thing around, if I, it just vibrates off. So I'm going to add on to that and maybe put a couple of extra ones in while I've got the welder going and grinding the paint off. So anyway, that's what I'm going to do to finish up this project for today. The cover that I have to cover up the machine to keep the grinding dust out, I don't think is going to reach beyond the drive motor, because I just added another 12 inches to the back of it. So I don't think my cover here is going to reach all the way across. So maybe I can nicely ask my wife to add on to that cover and sew it up for me. So out of all the tools that I have, the stuff that you don't want getting grinding dust in and things are the sheet metal tools, especially if you're dealing with aluminum and you get your dies all cluttered up. And even the press brake, if you get grinding dust all over that, that's an issue as well. And I do have a nice vinyl cover that completely covers that. So the sheet metal stuff is a relatively new addition to my shop, so I'm trying to get rid of the clutter and the mess and treat my tools like they should be treated instead of neglected, and hopefully they'll last a good long time. So alright, hopefully this was helpful for you folks. Alright folks, so this is wrapping up the bead roller and drive system. I've got my power cord hook on there. I got my little pocket to put my foot pedal in, and I added the extra long holder for these are shearing dies, and I got room for an extra set, and I put the wrench hanger on there. So gave everything a quick recoating of paint, and got my bushing all ready to go here for when I get the second bolt to hold it up. So the last thing that I need to do, and they give you a little guard here so you don't get your fingers caught between, that goes from these two bolts to here. Because my spacing is further away than what they intended, once I make the modification to the bracketry here to push it to the position that was intended, that gear cover will go on, and fit perfectly. Right now it's about a ½ inch too short, so I've got to move this in that much, and I can take up that space inside the couplers, and that should be 100% on this. So that's not going to happen for a little while, because I'm not going to do that until I get the second bolt, and then I'll finalize everything, put it into position. So anyway, once again, I hope that's helpful. So far this system is really working out. The recommended changes from some of the other YouTube fabricators on making improvements to the overseas version of the bead roller are absolutely exactly what should be done, and I'm super happy with this now. It really does perform like a professional version of it. That's probably 3 or 4 times the cost of what I have invested here. So, alright, now I've got to get back to what I should be doing, which is working on that and working on that. Alright folks, I've spent an awful lot of time getting this bead roller ready for action, and I decided to add a table because I saw a tremendous amount of benefit in that, and I also worked in a backstop or a fence. You can see that I have the full range available to me all the way up to the back side of the dies, and it travels on the stiffener that I made, and it just locks into position wherever I need it to go. So as long as I butt it up against this correctly, give it a little snug, it'll resist the twisting. The table just bolts on with 2 quick bolts right here, and I got to put this away and really get to the point where I can start making the sheet metal panels for the old modified here. So we're getting closer to that. I got some other things I need to do first, but the good news is hopefully my equipment will be ready to support that process. Alright folks, that's it for this time. Remember, if you can't be good, be spectacular.